In this section, we're going to talk about how to use combination and permutation to determine the number of ways a situation can happen. So we're going to look at an example first, and this is a very easy example. If you have 3 different shirts and 2 different pants, how many different shirt-pant combination can you have? So some of you already know the answer is 6, but let's say that you didn't, and let's see how we can actually figure this out. So you have different shirts and you have different pants. So let's say you have A, B, C type of shirts, and then you have 1 and 2 type of pants. So the first thing you're going to do is you're going to choose a shirt. So if you choose A shirt or shirt A, you can either choose pants A or pants 1 or pants 2 after that. So that gives you 2 combination, shirt A and pants 1 or shirt A and pants 2. You can do the same thing. Let's say you chose shirt B first, and you would have a choice of pants 1 or pants 2. Same thing with shirt C. If you were to choose shirt C first, then you have 2 choices, pants 1 or pants 2. And you can see that from each one, you have 2. So each shirt has 2 choices of pants. And since you have 3 shirts, you're going to have a total of 6 choices. So basically, shirts, you have 3 choices, and pants, you have 2 choices, which gives you 6. And that is a fundamental counting principle, which says if event M means like something like shirt, and you're picking a shirt, can occur in M ways, in this case was 3 ways, and is followed by event N, that is, in this case, picking a pair of pants, and that can happen in N number of ways, in this case, 2 ways. Then event M followed by event N can occur in M times N ways. So you multiply the number of ways the first one can happen, and the number of ways the second thing can happen. So let's look at another example. A typical California license plate is shown below. The usual combination is 1 digit of number, which is 0 to 9, followed by, usually start with one number, and then followed by 3 letters, and then 3 more digits. If the numbers and letters are allowed to repeat, how many different combinations of license plates are possible? Okay, so the way you do this is you think of it as event again. So first one is an event, second one's an event, and then so on. So in this license plate, you have 7 events. So 1, 2, 3, 4, 5, 6, 7. You ask yourself, in the first place, how many ways can you choose the first number? The first number has to be from 0 to 9. So how many ways can you choose the first number? Well, we know that there are 10 numbers, 10 digits available, so that's 10 different ways. The next thing that's going to happen is you're going to have to choose a letter. So then you ask yourself, how many letters are there to choose from? Well, there are 26 letters. So there are 26 ways. The next thing is you're going to have to choose another letter. Now the question says the numbers and letters are allowed to repeat, which means you can choose the same letter as the one you just chose. So then how many ways can you choose the next letter? Well, that's going to be 26 again, because you can choose the same one again. And so on. So then the next one is a letter, so that's 26. The next one after that is a number, so that's 10 ways, and then 10 ways, and 10 ways. So if you multiply everything together, you should get 175,760,000. So 175,760,000 ways to create this license plate. Okay, now let's go ahead and have you practice this next one. So it's another license plate question, and the license plate is going to be a little bit different. So go ahead and pause the video and try this problem and come back and check your answer. All right, so this one has 2 letters followed by 4 digits. And this one doesn't say if it's allowed to repeat or not, so we're going to assume that it does repeat. So 26, 26, 10, 10, 10, 10. And then remember the multiplying principles, fundamental counting principle says we multiply them together. So this is 6,760,000. Okay, so the previous example shows the number of combinations possible. Now we're going to talk about the number of ways we can arrange the given number of things. So for example, how many ways can you file 12 folders, one after another, in a drawer? So let's think about it. Like if you have a drawer and you're going to put 12 folders in there, and you're going to put the first one here, second one here, third one, and so on until you put in all 12 of them. The question is, how many ways can you sort out these 12 folders? Well, you can think of it the way that we did the previous question. So, you kind of think of it like there are 12 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You ask yourself, in this first spot, how many folders can I choose from? Well, you have 12 folders to choose from because you haven't put anything in yet. Once you put that in, you ask yourself, how many ways or how many different folders can I choose from to put it in the second spot? Well, you already put one in the first spot, so you only have 11 choices left. And then you're going to go to the next one. How many ways can you put a folder in the third spot? Well, you already put in 1 and 2, so you put in 2 folders, you only have 10 choices left. So that's multiplied by 10, and you can see that this is gonna just count down like so. And then you multiply that all together, you get 479,001,600. Okay, so there are that many ways to rearrange 12 folders one after another in a drawer. Now, there's another way to say what I just did, which is multiply from 12 in descending order down to 1. This is called factorial. Okay, so let's look here. This is called factorial. Factorial is this exclamation mark thing. So when you see 5 exclamation mark, you don't say 5 exclamation mark. You say 5 factorial. Okay, and I wrote that here. 5 factorial. Now, what's 5 factorial? Basically, what you do is you multiply from 5 down to 1 in descending order, and it's only integers. So 5, 4, 3, 2, 1. And then if you multiply all that together, let's see, you should get 20 times 6, 120. So then same thing here. Another way to write what we just did for the folder is 12 factorial. Notice this one is a little bit different. What does it mean when you have a 0 factorial? 0 factorial, because we have to kind of give it some number. 0 factorial is just 1. Okay, let's go ahead and have you practice these. Let's have you do it without the calculator. So 1, 2, 3. Go ahead and pause the video and come back and check your answer. All right, go ahead and check your answer. The last thing we're going to do is this thing about permutation and combination, kind of a general way of figuring out how many ways we can rearrange something. So if you are given a set of items, you want to find the number of ways to rearrange them, you'll either use permutation or combination. Okay, what's the difference between them and what does it mean? So permutation is basically used when you're going to say, okay, the way I rearrange them, order matters. What does order matter? For example, like the previous question, you're going to put the folder in one after another, meaning you have an order to this. This is the first spot, this is the second spot, this is the third spot, this is the fourth spot, this is the fifth spot. So somehow there's an order to this, or for example, you have like 5 students. You're going to figure out how many ways can you pick the president and the vice president of, say for some reason, some kind of club. So the president cannot also be the vice president, so then the order matters. For combination, it means order doesn't matter. So it really doesn't matter who's, first and second. So for example, let's say you have a bag of M&Ms and you have, let's say 50 M&Ms in there. The question is, how many ways can you choose 10 M&Ms? And let's say there is no difference between the 10, or you just don't really care which one of the M&Ms come out first and which one comes out second. Then the order doesn't matter. You're just choosing 10 altogether. Then you're going to use combination. Okay, so let me kind of give you some formulas. You're probably not going to use the formulas that often, but just so that you have it. So for example, NPR. Okay, this P means permutation. This N here means the total you can choose from. This R means how many to choose at a time. Okay, when you see this, what you do is you do n factorial over n minus r factorial. For example, 5p2 or 5 permutation 2. So this is the total. So you have 5 things. You're going to find how many ways can you choose 2 things, 2 out of 5 things. But order matters. Okay, so let's use the formula. 5 factorial, so 5 is n, so 5 factorial over 5 minus 2 factorial. All right, this part you got to do that first, because remember Pam does, you got to do the parentheses first. So let's go ahead and simplify that. So this is 5 factorial over 3 factorial. Just like the previous questions or the practice, write this out. That cancels, so this is 20. Okay, for combination, the formula is kind of similar. So you have NCR. N again is total, C means combination, R is how many you're choosing at a time. The formula is n factorial over n minus r factorial. So far is exactly the same as the permutation. The only extra thing is to divide by r factorial again. And let's go ahead and practice this one. So I'm using the same numbers as before, but I'm just changing it to a C. So let's go ahead and apply. So 5 factorial over 5 minus 2 factorial, and then divide by 2 factorial. So let's go ahead and do this one. So 5, 4, 3, 2, 1. 5 minus 2, we already know that's 3 factorial. So 3, 2, 1. And then 2 factorial is 2 and 1. So these 2 cancels out again. 5 times 4 is 20 divided by 2. So this is 10. All right, go ahead and pause the video and give these 2 a try. All right, these are the answers for for this practice. Now, what you want to do is figure out when do you use what, and then how do I figure out how to calculate it once I figure out if it's permutation or combination. So the way you do this is you ask yourself, does position matter? Or am I choosing a small group out of a big group, which means the position doesn't matter. So for example, the first one, a chemistry teacher divides his class into 8 groups. Each group submits 1 drawing of the molecular structure of water. He will select 4 of the drawings to display. In how many different ways can he select the drawing? So he's trying to get 4 drawings out of 8 drawings. You ask yourself, does the order in the way he picks the 4 matter? Not that whether it matters to him or not, but just like the 4 drawings he's picking. Does it matter? Okay, in this case, it doesn't matter because he's just picking 4 things. We're not saying like the 4 best ones. We're just saying he's just picking 4 out of 8. So this one's going to be a combination question. So we're going to set this up. So we know this is going to be C. The total number of things he can choose from is 8. He is choosing 4 things. Now, what you can do is use the calculator, and I'll show you when we come back to class how to use the calculator. But you can just do 8 factorial over 8 minus 4 factorial for now, and the answer is 70. Okay, let's go ahead and try this next one. Go ahead and pause the video, select which one you think it is, and come back and check your answer. All right, this one, because it is drawing from a raffle ticket, and the order matters, because if you're the first one that comes out, you do get more money. And so the order will matter for this one. So this is a permutation question. So let's go ahead and set this up. There is a total of 25 raffle ticket, and this person, or you are selecting 3 ticket. And because the order matters, you put a P. Okay, and after some calculation, the answer is 13800. All right, again, pause the video, try to figure out whether this is permutation or combination, come back and check it. All right, this is the same kind of question as before. First, second, and third places are going to receive different prizes. So this is going to be permutation. So 10P3, which is going to give me 720. All right, last one. Go ahead and try this one. All right, this is going to be a combination. You really don't care which potato comes out first. So this is 12C5, which is going to give you 792.